Hello, I'm Brad from Geon Technologies. This video will be the first in a multi-part series designed to introduce REDHAWK users into experimenting with REDHAWK's new prototype containerization capabilities. REDHAWK's containerization capabilities support running waveforms on container orchestration technologies like Docker Swarm and AWS Kubernetes via cluster plugins. End users can use the provided Docker Swarm or EKS plugins or even write their own plugins. In this first video, we'll cover how to quickly create a virtual private cloud, or VPC, within Amazon Web Services, along with the Kubernetes cluster provided by Amazon's Elastic Kubernetes Service, or EKS. REDHAWK comes with so-called cluster plugins for both Application Factory and Sandbox, for Docker, Docker Swarm, and EKS. We're going to be using the EKS plugin in this series. Before we configure REDHAWK and install the EKS plugins, we need an EKS cluster to run our REDHAWK waveforms on, and that cluster needs to be deployed into a VPC. So that's what we're going to accomplish in this video to show you just how quick and easy it is to get these infrastructure dependencies out of the way. We are ultimately going to be building up to a point where our REDHAWK system, running inside of another VPC, can run a REDHAWK waveform on our EKS cluster. You could just as easily have your REDHAWK system running on premises, so long as it has network connectivity to reach the VPC housing your cluster. Network particulars will be discussed more in the next video, but for now, let's get started building. To quickly create our VPC, I'm going to use this shell script that uses the AWS CLI tool to make the API calls into AWS for us. The script sets a few variables dictating the VPC's network and subnet partitioning. So if you want to change your VPC network configuration to better suit your environment, you can modify these variables to your liking before running the script. The script checks to ensure that you have JQ and AWS binaries installed and available for use. Most importantly, the script assumes that you've already pre-configured your AWS CLI binary to use a proper IAM user or profile with the credentials needed to create VPCs and EKS clusters. For more information on configuring your AWS CLI utility, please consult AWS's official documentation. My system has JQ and the AWS CLI tool installed, and the AWS CLI tool has been pre-configured with the needed IAM permissions, so we're ready to get started. Let's run the script. The script will build a VPC with the CIDR block set in the script's variables and partition it into 4 subnets. One public subnet to house the internet gateway for facilitating internet connectivity for resources in the private subnets, and 3 private subnets, one for each node we intend to have in our EKS cluster. The script will create a NAT gateway and an internet gateway, as well as configure route tables for both private and public subnets. What this script will not do is set up network connectivity to your VPC from your environment where your REDHAWK system resides. Ultimately, you'll want your system with REDHAWK installed on it to have network connectivity to your VPC, and depending on where you run that REDHAWK system, you may need to set up a VPN connection to the VPC or something else, again depending on your particular environment. Now that the VPC and associated resources have been created, let's take a quick look at the AWS console to visually verify everything has been created to our liking. Our VPC is here, and we have our 4 subnets here. We also have our 2 route tables here, one for the public subnet and another for the 3 private subnets. The routes in these tables have been configured to facilitate internet access by directing traffic from the private subnets to the NAT gateway and traffic from the public subnet to the internet gateway. Finally, we'll also confirm that our Route 53 inbound endpoint resolver has been created in this VPC. And yep, it looks like that's there, and they are ready for us for use later. We're now ready to move on to creating the EKS cluster. AWS provides a handy tool for creating EKS clusters called EKS CTL, or EKS control. You should follow AWS's documentation for installing this tool on your system as well. The way it works is wherever your EKS CTL command is being ran from, it calls AWS APIs over the internet to create your cluster. The first step of this process is the EKS service provisioning a Kubernetes control plane. Once the control plane is ready, EKS CTL moves on to creating the actual virtual machine nodes that comprise the cluster. EKS CTL needs access to this control plane in order to join the nodes together into a cluster, which is why the cluster is created initially with both public and private access points. The public access points are needed for EKS CTL to fully complete creating the cluster. Once the cluster is built, it can be reconfigured to only provide access via VPC private endpoints. We minimize the threat profile by whitelisting our public IP address as the only one authorized to send Kubernetes API traffic to the control plane over the internet. You could choose to, alternatively, create an EC2 instance inside of your VPC, install the EKS CTA tool on that machine, and then run the cluster creation process from within the VPC to make the cluster only use private endpoints from the get-go. But we're going to build the cluster from our REDHAWK system, which is located outside of the VPC, for this demonstration. Let's walk through the cluster configuration file we'll use to build our cluster. First, we have our cluster name specified here, as well as the region where our VPC was created. If you installed your VPC to a different region than the one that I'm using here, update this line to reflect that same region. You can see here that both private and public endpoints are being used for cluster creation, but again, we'll remove the public endpoint once the cluster has been created and we've whitelisted our public IP address on this line here. Let's take the subnet IDs returned from our VPC script and modify our cluster configuration file to use those subnets. The final section of this file controls the VMs used as the cluster nodes. An important design decision here is how large you want the VMs to be, their EC2 instance type. EKS uses a special network plugin that makes Kubernetes pods share the same IP address space of the VPC housing the cluster. In other words, pods will use your VPC's CIDR block addresses. EC2 types directly influence how many pods they can run according to how many virtual IP addresses they can support. This official resource provided by AWS can help you size your cluster to ensure that you will have enough IP addresses to run your anticipated number of pods. Keep in mind that EKS comes with some pods in the kube system namespace that eat into the total number of pods supported. Our T3 2x large instance types will support 58 pods per VM. Our desired capacity value in our configuration file requests 3 nodes to be running simultaneously, so 3 times 58 means that our cluster can support a total of 174 pods. Let's go ahead and create our cluster. We're going to use the EKS CTL tool and tell it to create a cluster specified by the file argument that we give it, in our case, the configuration file that we were just looking at. Now that the cluster is creating, this process will take about 15 minutes to complete, so we'll go ahead and fast forward through this and be right back. Now that our cluster is created, let's make sure we remove the public endpoint to make our cluster fully private. EKS CTL utils update cluster endpoints, and we'll specify the cluster name, REDHAWK cluster. We'll set the private access to be true and the public access to be false. Okay, all done. If we take another look at the AWS console, we can see our created cluster nodes from the EC2 service view. And from within the EKS service view, we can see our created EKS cluster. This concludes the objectives for this video of creating a VPC and provisioning an EKS cluster into it. In the next video, we'll turn our attention to configuring the EKS cluster in preparation for REDHAWK and discuss some networking particulars. See you there.